Multiple sclerosis is an autoimmune disease which chiefly involves the degradation of the myelin sheaths of nerves in the spinal cord. In the U.S., multiple sclerosis, although typically not lethal on its own, leads to an 80% increase in mortality later in life. As a result, it is crucial to receive an early, accurate diagnosis in order to properly treat it. Otherwise, if one is one of the 20% of patients misdiagnosed for MS, very real dangers present themselves. For example, in an NIH study, Andrew J. Solomon and associates found that 30% of a group misdiagnosed for MS died unnecessarily. The current method of diagnosis is the analysis of MRI scans of the brain in the presence of lesions. However, as mentioned before, doctors are humans and make mistakes, leading to the aforementioned 20% misdiagnosis rate. As a result, a more precise mechanical end is needed when analyzing MRI scans, introducing a machine learning model to diagnose MS from MRI scans. The expected outcome of the project is to create a model that can diagnose MS with an accuracy of 90% or above. An accuracy of 80% or above would exceed the status quo, but the higher the accuracy, the lower the rate of misdiagnosis, so it would be better to expect more. If implemented, it would cut misdiagnoses by at least 50%, therefore reducing the deaths caused by them. The data consisted of 70 scans for people with MS and 101 control scans for 3 different data sets. The scans were all T2 flare scans to control for the different methodologies of taking them. They were all shuffled to make sure that there were an even distribution of positive and negative data. The model itself consisted of a pipeline of standard scalars trained into a neural network implementing SGD. It will be written in Python and use the scikit-learn package. The standard scalar is crucial in normalizing the data by moving all the data points closer to the mean. After all, the data did come from different data sets to account for the variances in the method of data collection. The scalar made them more useful. SGD will be used to feed the data one bit at a time so that the model doesn't become too accustomed to the nuances of the data set. With respect to testing, the model's accuracy will be evaluated on completely new data from the data sets that the model had never seen before in order to make sure that the model will be able to receive actual scans. With respect to risk, no risks are present. This is because there are no physical elements or chemicals used in the conducting of the experiment. To analyze the data, the standard deviation will be logged using the expected experimental values taken, and the effectiveness of the model will be determined by the overall accuracy percentage of the test results.